Good afternoon. This session this afternoon after lunch is about inventory valuation techniques. My name is Marco Russo. I'm a consultant for SQL BI. Silence your cell phones. You can find my articles and other tools on sqlbi.com. I wrote a few books. And actually, what I'm going to show today is in part described in one of the DAX patterns that I will mention, but in part is something that we still didn't publish because it's part of some problems we faced with other customers. It is still not ready to be described in a pattern, but I think that there are many considerations that we can share together, and so I will spend some time talking about this class of problems. So we will focus this time on a specific problem, which is how to provide a value to the goods that you have in your inventory. As you may know, there could be several different techniques that you can apply, and a few of these techniques require some program, like a C# program or SQL store procedure, because they require a row-by-row process, and these techniques are very inconvenient to be implemented in DAX. At the same time, there are other techniques that could be implemented in DAX in a very efficient way, and we can use these techniques for several reasons. One is you want to create a simulation model in Excel in order to see what would happen if you use a different evaluation technique. There are companies that use different techniques for different reasons. For those of you that are not maybe into this type of problem, it could seem, okay, if you have a few objects in your warehouse, the value is the value that you, the cost that you spent to buy these goods. But actually, the prices could change over time. You might have different techniques to evaluate this. You might have some raw material that changes the price in the market. So there are many conditions in which this could be different. So the idea is that we're not going to understand why we may need different techniques. The point is that these techniques are, well, techniques that are very common in different businesses, and we want to spend some time understanding how much of this problem can be solved in DAX, how much of this problem is easy, how much is complex, how much is impossible. So we will focus on this stuff. So let's start to see what are the scenarios, and I will spend some time describing you which are the techniques that we can use. For some of you, how many of you already know first in, first out, last value? Can you raise your hand? You are familiar with these ideas? Almost everyone. However, we just do a quick recap, and for those of you that may be not familiar, this could be the good time to understand what was going on. So the first step is what are the data that we have? Usually, you have this. Let me start with the first, no, this one. We have to start with the inventory, this one. So usually we have this. The common data that we have is a table that contains a number that represents the amount of goods, amount of products. For each product, for each date, we have the quantity that we had at that particular day in a warehouse. In our warehouse, or we might have the warehouse key. We try to keep the model very simple in these cases. I know that there could be many, many different attributes. But the idea is that one common technique is that in a table in my database, for every day, I store the quantity for each product. And if this product tomorrow will not have any sale and any new purchase, it will store the same number every day. This technique makes it very easy to get the amount, the quantity, just the quantity. By now we're not talking about the value. We're just looking at the quantity that we have at that particular day in our warehouse. And this is the column units balance. Now, if you look at the number of rows, the number of rows that you have in your inventory is particularly high, depending on different conditions. One is the granularity that you want to store in your database. If you want to get the data every single day, you want to get the daily granularity of your trend for the warehouse, and you have 1,000 products, you will easily get 365,000 rows every year, and so 700,000 for 2 years, for example. So the point is that sometimes in certain businesses, this is a fraction of the transactions that you will have considering all the transactions of sales and purchases. Because for every product, you have many transactions every day. But for other businesses, the situation is actually the opposite one. This number could be much larger than the number of transactions that you have considering all the warehouse transactions. So the other condition, so this is usually what you will find in many ERP systems. However, in the same ERP system, you usually have this other table, which is, let me just get this one. This other table in the Power Pivot data model has the same information from a logical point of view, because these are the current transactions, the products that I bought and the products that I sold for every single transaction. Now, if you don't have at least one transaction for every product for every day, what happens is that you have a number of rows for the same amount of time that is usually a smaller number of rows. And sometimes the difference can be 1 or 2 orders of magnitude. In order to avoid this type of volume, data volume, for businesses that have 100,000 products, 1 million of products, a large retail store may have easily 1 million of SKU. It happens. And when you have this amount of volume, keeping the data every day means a lot of data, 1 million rows every day. If you have 300 shops, multiply this by 300 shops, and it's 300 million of rows per day. Whereas if you look at the transactions, it's a fraction of these rows. So the idea is interesting. Why I had to store this huge number of rows. We call this the quantity every day, stored every day. We call this a snapshot. We do a snapshot every day. So why we had to get a snapshot instead of getting the transactions? Yes, the snapshot is easier to query. If you have SQL Server, Access, Oracle, the query that results is very easy. You apply a filter over a date, and you get the number. Easy. The problem is that it is expensive in terms of resources. Now, if you have a database on disk, the disk is large, and you just access the fraction of the disk that you are interested to retrieve the numbers that you want, and that's fine. However, when we think about our Power Pivot model, our tabular model, when we think about DAX, we have all the data in memory. Now, having all the data in memory is a different story, because if I have all the data in memory, I probably prefer to have just the movements in memory instead of the entire snapshot. So the question is, wait a minute, can I obtain the result that I have in the snapshot table without actually storing the snapshot table? And the answer is yes. The second question is, yes, this is possible also in SQL. The second question is it better or is it good enough in terms of performance or not? It depends. But the point is that with Tabular and with DAX, this could be easily a scenario that makes using the transactions faster scenario than having the snapshot in many conditions. Not every time. You have to evaluate the situation, but it could be faster. So the snapshot is a condition where we have one row per day, product and warehouse. Depending on the business that you have, the snapshot could be larger or not. If you have a snapshot that is smaller in terms of number of rows than the number of transactions, no questions, use the snapshot approach. Use your, your snapshot every day, you store the data because it's a smaller number of rows. But when the snapshot is larger, then you have to make some consideration. Sorry, this is... Fundamentally, we have to compare the space. And usually, you make some test. You analyze the volume of the table in terms of not just of rows, but also of sites in memory, because also the compression that you can obtain is important. And in this case, the case that I shown you before, we had 600 products and an average of 33 transactions per day. And in this case, the moments table was better than the snapshot table for a number of reasons. However, you have to do this math for your specific scenario. Now, if you have this scenario and you want to apply a DAX formula to evaluate the quantity, because in order to obtain the value, first we have to calculate the quantity. We have to implement a particular DAX formula. Is it better than the snapshot or not? It depends. This part is already described in a pattern on the website daxpatterns.com. It's called the cumulative total, and I show you now how it works. So we can go to the, wait a second, we go in this one, and we can examine this situation. So in this case, we say, okay, we have a model that is very simple. We have the date and the transactions. We don't need the product table in this case just to show the formula. And what we want to do, we want to obtain, starting from the transactions, look at this table. This table is very easy. We have only 2 products. We have the quantity for each product, and we have the data of each sale. However, if you see, we have a few dates, but we want to obtain the snapshot for every day, also the days in the middle, so that in this way, when we will see the pivot table, we should be able to drill down every month at the day level, also for the days where we don't have any data. So this is the goal. I'm using a very small table now because I want to make it clear how it works. So the cumulative total is a formula that has to sum all the transactions that we had for that particular product since the beginning of the history. So the idea is that if you store all the transactions, you start with the empty warehouse and you store all the transactions, you sum everything since the beginning of the history, and you obtain the amount of the quantity at that particular date. How it works in DAX? Actually, is not so difficult because the formula is the following. I hope the lights are too strong. Fundamentally, we do what? We sum the quantity, which is this DAX formula, and we apply a filter where we want to include all the dates that are less than or equal to the maximum date of the current selection. So if you are selecting 1 month, the maximum value is the last day of the month. And so by applying this filter, you say, okay, I want to get all the days since the beginning of my history. Of course, if you have only 1 year of transactions, you should include before the first transaction a date in the past that contains the initial stock value for every product. Once you have this, you obtain this result. This cumulative quantity unchecked value. And of course, if you apply the product filter here, you will see that you have the total for the shirt product and the total for, oh, we have only shirt here, and the total for the bike product. So this is bike, this is shirt. I can put the product in the filter, so it's more clear probably. If I do this, only bikes, and I have a number, only shirt. So this works. Problem, as you see, my transactions, my last transaction ends in April 2013. So what's the meaning of looking at data in May, in June? Doesn't make sense, right? Because if I had transactions until a certain date, I don't want to see the quantity in the future. So we just have to apply a condition that says, okay, if there are no more data, no more transactions, I stop displaying data. So I want to obtain as a result the cumulative quantity, so that if I remove this measure, I will see that I have data until April. Because otherwise I see the entire calendar that I have in my date table. How can I obtain that? By simply applying an if condition that says, okay, if the first date in my current selection, you are selecting 1 month, the first day of the month. You are selecting 1 year, the first date of the year, or 1 day, that day. If this day is less than or equal to the last day that I find in my transactions table, considering all the products, all the transactions, then I want to show this date. I want to show that month. But if I have data until April, if you select May, you don't want to see anything. You know that there are no transactions for any product, so okay, probably we are in the future. I don't want to display the quantity in the future. So this is a simple technique. And so my calculate here evaluated the maximum value of the date for all the transactions. So this is the check that I do. So this is just the quantity. Makes sense using this pattern or not? As I said, you have to test it. You have to test it with your data. In some businesses, this is way faster and less expensive. You consume less memory. In other businesses, it is too slow. And so you have to rely on the snapshot approach. Now we solved 1/2 of the problem, which is, okay, I want to get the quantity. This is the same measure that I shown you in the Power Pivot model. And now we can approach the real topic of this session, which is, okay, now we want to provide a value to this number. At this point, I have to do a small digression about which are the possible techniques that we can apply. Actually, there are probably much more than these ones, but these are the more common ones. And one technique is the last price. Can you correct me? Is LIFO FIFO the right pronunciation? Because, okay, you say in this way. Because in Italy, we say LIFO FIFO because we have a different pronunciation. And I never heard, because I usually use last in, first out, first in, first out. I never pronounce this in English. And we have also different techniques for the average. One interesting condition is what happened to all of these techniques, in particular excluding the last price, what happened when you have an out-of-stock event for one product, which is something that makes the calculation harder to do using a simple aggregation. So let's take a look at these different techniques of evaluation. So let me find the right one. Okay, let's start from this. So here we have a table where I prepared a very simple description of a scenario where we have purchases, sales, and the actual balance that we have in our stock. So I will spend 1 minute describing this transaction because we will see the same transactions in different techniques. So I bought 100 units of a product at the price of 10 on 15th of January, and the global value was 1,000. So at that day, the quantity on hand was 100, the value on hand was 1,000. Easy. Purchase price. Now I sold 50 units at the sales price. I don't care. I just care about, okay, what was the cost of the goods that I sold? Now, the cost is this one. The price that I spent to buy these goods the last time is the price that I want to consider also for the sale. So what I have in my warehouse is the difference between this one and this one. And so fundamentally, I have this result. Now 5 days later, I buy 20 units at a different price. And now we can see the differences between different techniques, because at this point, the value that I have is my 500 plus 300. But at this point, it depends. Because in reality, if I consider what I spent until now, yes, I spent in total 1,300. But what is the value of the goods that I have here? If I use the last price is a technique that says, okay, get the quantity that you have in the warehouse and multiply this quantity by the last price you had as a purchase price for these goods. At this point, if I use this technique, my value is 1,050 instead of 800. Why I have something more? I added value just because the price increased, and in this technique I want to see this number. At that point, every time I have a sale for these goods, I always apply the last price. So as you see, once I have 15 here, any following transaction and all the evaluation use this 15. Okay, this is one technique. And this is easy to implement in DAX. We will see how to do in a moment. FIFO, first in, first out. In this case, we have the same scenario, so I only concentrate on what happened in the balance value here. As you see, here the value is 800. Why? Because every time first in and first out means that what I consider as a price for my sale is the price of the first product that I bought. So fundamentally, it's like having a queue, and what I'm selling is the first thing that I bought. So my purchase of 20 here is something that I will sell here. In fact, you see that the entire amount of sales for this quantity 50 is evaluated at a price of 10. This is important because the remaining part, what I have in the warehouse here, the quantity is 20, but the price is 15 because the 20 that I have at the end are this one. First in, first out. That's the idea. Implementing this technique is very hard because for every transaction, you have to evaluate many possible conditions, and is practically impossible to do this with a functional language like DAX. There are solutions to this problem written in SQL. I have seen stored procedure, but fundamentally it is computationally very expensive. Because unless you can store the value row by row, and for every row you consider what you had the last time, this is hard to implement. And even if you save for each row what you did, the problem is that here, having the price is not enough. Because this price, at a certain point, has to become 15. And the transaction that you have here has a value of 10, which is important for the margin calculation, because the following part that we don't see in this session is how to evaluate the margin. So in a business that implements this technique, you have to rely on some external system that evaluate the price for every transaction and for the value that you have on hold. LIFO is similar in the sense that it works using the same technique in the opposite way. What does it mean? When I do this sale, 50, my 50 includes 20 of the last purchases and 30 from the first one, which means that the 20 that I have here have a value of 10, which is the initial value, because last in, first out. So this 20 is solved here, and also in this case, obtaining this evaluation is something that you cannot do in DAX. Cannot do in a meaningful way. I mean, probably we tried, I and Alberto spent some time trying to figure out if there is a possible solution in DAX. But even if this solution exists, and we are not sure that it can be done, but even if you can do that, it would be very, very, very slow. Because for every row, it would iterate all the previous rows, probably with an order of complexity, which is O n factorial n, at least, or O square n. So is too high. Average. The average technique means that is what probably is the common sense, right? How it works. Until this transaction is, of course, is easy. At this point, my value is 500 at, 50 multiplied 10 plus 20 multiplied 15. So if I sum 500 to 300, I have 800. And this is the average. I apply an average. So from this point, I have an average price of my warehouse, which is 1143. And whatever I do, I will sell at that cost price. So all the following transactions have this value, and unless I do a new purchase, this value will not change. Now, this is easier to implement and can be actually implemented in DAX. But what happens if there is an out of stock? It would be easy if this would never happen. Unfortunately, in the real world, any business expects that if at a certain point my product goes out of stock, from that day I will restart my average. I will ignore the previous transactions, the previous purchase transactions. Okay? Which means that I cannot simply sum the previous purchases. I have to sum the previous purchases until a certain date, which is the last out-of-stock event. Now, the average assumes that for every day you do the evaluation, there is an alternate or a combination of techniques, which is the average period, which is we don't care about what happened within a month or within a period, a week, whatever. In this case, 1 month. Within that period, in this case 1 month, we sum all the purchases, no matter in which order they are. And we evaluate the entire all the transactions in this period at that particular average price. This particular scenario means that even if I bought this product on 15 January and I sold this quantity on 20 January, what I did in 25 January affects the price, the cost price that I had for a transaction in the past, because it is within the same period. And certain businesses want to do that. In this case, we are very lucky, because in this case, DAX works very well. However, also in this case, I may want to do this. Okay, everything is good, but if I have an out of stock, then wait. Out of stock means line and restart the calculation. So we have two averages in this case. Okay, I set the baseline for the calculation that I will show you. And as I anticipated, LIFO, FIFO, no, sorry. We will see last price and we will see the average. Now, the last price can have two variations. I may evaluate the last purchase price or the last selling price, which are two numbers that are not exclusive. I can use both, because one represents what would be the cost of the products that I have in my warehouse if I buy these products today, last purchase price? Or what is the potential revenue of my warehouse if I was able to sell everything today at the last price, at the last selling price? So usually is something that can estimate the potential revenues instead of getting a value of the cost. Now, how we do that? We have last price. This one. This one, yes. And this technique is relatively easy. Why? Okay, in this model, we have the movements. So we evaluated the quantity in a dynamic way. And we created this formula that says, for each product, I multiply the quantity, units in stock, by the last buy price or last sell price, depending on what I selected on a particular item. So, sorry, depending on the availability of a sell price for that product. So if I never sold this product, I will use the purchase price. Why I have to do a sum X product by product? Because every product may have a different price. So the only difficult part is how I evaluate the last buy price or the last sell price. But this is a relatively easy calculation. It is complicated only by the fact that we may have a few exceptions, and so we handled all of that. So the idea is that, first of all, the last buy price can be evaluated only if we are selecting a single product. So if I try to call this measure having more than one product selected, I will return blank. Now, if you think about, I write in the previous formula, I had a sum X. So I will call this measure within a loop that iterates every product. So for each call of this measure, I will have only one product selected. But in case I make some mistake, you know, we can handle that. At this point, I have to get the last transaction of this product, the last purchase transaction of this product. And I do that by doing this. I want to evaluate all the transactions that I made before the data that I'm considering. And so I apply this filter. I want to consider only the transactions that are purchases. I have a flag, it's purchase. Now you may have the quantity. Quantity positive is a purchase, quantity negative is a sale. However, it is much better if you have a flag, because from a performance point of view, I'm applying a filter on a column that has only true, false, only two possible values. When you apply a filter on a column that may have different numbers, when you write quantity greater than 0, you're applying a filter over a potentially thousands of values, thousands of unique values. It is much more efficient. Remember, we have to evaluate this for every product, so performance are important here. Then we have a top N one. What are we doing here? Fundamentally, we have to get the last day where we had some transaction. And so by applying this calculate table, using the filter, using is purchase, top N returns the first date in the order, so from the greater, so fundamentally the last date available in that period where we have some transaction. And we apply the result of this to this. Now the problem is, what are you doing, Marco? You have an average X and you evaluated the average over unit cost. Well, the problem is that if you look at this top N, in reality I'm getting the top N movements, the top N rows in the movements table. I may have had several transactions in the last day. And in that case, I want to calculate the average of the price of the several purchases in the same day. So we are considering, if we know that we have only one transaction per day, this formula would be much simpler. We do the same also for the sales. We just change the flag, which is not is purchase true, but is purchase false. So it's not. This is the only difference between the two measures. And in this way, we obtain this. As you see, for every day, I can see for all the products the sum of the value using the purchase value or the sale value. Usually, I hope for your business that the difference is larger than this example, but fundamentally, we can navigate at any day, and the performance are usually very good. The performance depends on the number of products you have. You have 100 products, very fast. 1 million products, you will start to see something slower, because for every product, it has to do this calculation. Okay. So these are the formulas that we have seen. And now we can see the average. The average is a technique that allows us to do a calculation. This is probably the more common calculation. The problem of this calculation is how to handle the out-of-stock event, which is fundamentally the biggest issue. And I will show you a technique that is very efficient in DAX, even if I think that you will not use this technique as it is in Power Pivot. Probably it is good for Tabular for a number of reasons that I will show you, but it is a starting point for your analysis. Okay. Let me show you. Okay. No, this one is the one. Average period is this one. Average period. This one. Okay. 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 In order to apply this technique, I had to do one operation in advance, which is we created, starting from the inventory movement, which is the table that has all the transactions, we consolidated this table into a table that has one row per day per product. Why this is important? Because having more rows for every day is something that creates too large complexity. You have seen in the first example that just to get the last price, we had to get an average X in the middle of something else. So I prefer to avoid that. So in order to obtain the daily movements, what we can do, for example, we start from this table. This is the table that we have from our ERP system, for example. We can create the daily movements table in this way. Fundamentally, I have a DAX query in this case, but you can do this in SQL if you prefer, where I fundamentally group all the transactions that I have for one product in one day in one warehouse. And I group all of them, grouping all the purchases and all the sales. So I have a maximum of 2 rows per day per product per warehouse. Why this is important? Because I want to do this. Once I have 1 row per day per product, I might have actually 2 rows per product because I have is purchases true and false. I put this data in a Power Pivot table, and I start to evaluate the average price for what? Well, I'm considering now the average of a period. So I'm considering not the average row by row, because if I had to do the average row by row, I should have to implement this technique for every day, which is very expensive. Unless you have very few products, it will be very, very expensive. I will rely my calculation on calculated columns. And the problem of a calculated column, the calculated column is evaluated for all the rows of a table, even when you process one partition. So when you have a pivot table model, a Power Pivot model, usually you don't have so much data. But if you want to implement these techniques on a table that has a few million rows, maybe 1,000 products, nah, not a good idea going at the day level. So the average day by day can be implemented in DAX. It is just probably too slow to implement because we have to rely on the calculated column. So my problem is, just to recap, this one, average period out of stock. So fundamentally, I know that I have a period, and I want to calculate the average price for that period. Now, my period is the period until the out-of-stock event. So my first goal, I have to know when I have an out-of-stock event. So in order to detect this condition, I created a quantity on hand calculated column. If you remember, the quantity on hand was a measure in my previous examples. Now this is a calculated column. So for every transaction, I know what was the final quantity on hand for that product at that particular day. And this is the same calculation that you have seen in the measure wrote into a calculated column. So for every transaction, now I have the quantity on hand, the quantity. At this point, and here is the trick. For the following calculations, I had to identify my, my period. And the period ends in the day where I have a quantity on hand equal to 0. And starts when I have quantity on hand equal to 0, the previous time. So I created two columns. One that is called last out of stock, and the other is next out of stock. And the idea is that my period is made by all the transactions that are within these two dates. So this last out of stock is this formula that fundamentally says, give me the last date in which quantity on hand was 0 for the same product in previous dates. This is what I'm doing. This calculate statement examines all the previous transactions of the same product and look for a transaction that has quantity equal to 0 and gets the maximum date, because I might have different out-of-stock events. I want to get the last one. The other column, oh my God. The other column does the same for the future and gets the first one. The first one in the future. The first in the future, the last in the past. These two events are my period, within which I want to evaluate the average cost of the purchases of that particular product. At this point, you may say, okay, Marco, so we have to create a filter where we get all the dates between last out of stock and next out of stock. Yes, but think different. We have to filter rows in this table. It could be easier to say, well, in this row, I want to evaluate for all the rows that have the same dates here, I want to evaluate the average. So I can simply write this, which is sum the value I spent in all the purchases for all the rows in this table where I remove the filter except the code item, which is the product code, the last out of stock, and the next out of stock. So fundamentally I say, if these three columns are the same, group everything together, which is the faster way to obtain this result. If you try to write dates between, you apply the condition on the date, it works. It is just less efficient than this technique. Because this is equal to one value, which is faster. So fundamentally, I consider all the transactions within this period, and this works also for the null. The good thing of using all except is that it works also if the condition is blank. Whereas if you try to write equal to, then you have to write or is blank or something like that. All except is very, very, very useful. What I do at this point, I sum all the values, all the quantities of purchases, and the division between value and quantity is the average price period, which is what you have here. Divide this one. Actually, I only need the price, but I'm showing you everything to show you all the steps. Once I have this value, and as you see, this value is the same value for all the transactions of the same product in the same period, I will use this value to multiply this value by the quantity on hold, and I obtain the inventory value, which is simply the multiplication between quantity on hand and average price period. So why I'm doing this stuff in DAX? You may say, well, any system, any inventory system, do this in the table in SQL, store the data, and you don't have to worry about this stuff. Right, correct. What if you want to do a simulation? The good thing here is that if I have to simulate what happened if I made, if I had a different price, if I had a different quantity, if I moved the goods, whatever you want to do, once you apply the change to the original table, this evaluation is completely recalculated for all the transactions automatically. It's a calculated column, and is usually very fast. I mean, if you have billion of rows, it's not so fast, but it's faster than any other technique, which is what we want to use. And this is the reason why we want to use probably this in DAX. So let me show you what I did fundamentally. We have to calculate we had to calculate the daily total. So for every day, we want to calculate the total, and we did this with a group by in DAX. But the reason why I am using this technique, identifying the period and calculating the average for a period, is that how can I solve the problem of having the calculation month by month? Because, okay, I don't have any out of stock, but I want to evaluate the value month by month. The technique here is that once we have written this algorithm, we can use the same algorithm also by defining an arbitrary period by just creating transactions that defines an artificial out-of-stock event. And let me show this, what we did in an animation. So we fundamentally created one row per day. So instead of having several transactions for the same day, as you see here, January, 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 different transactions, we obtained this table, where we have only 1 or 2 rows per day, because we may have 2 rows because we group all the purchases and all the sales together, but in 2 different rows. Once we have this table, what we had to do, if we want to consider January and February 2 different periods, we had to inject a transaction at the end of January and a transaction at the beginning of February that creates this condition. On hand has to be equal to 0, right? Now, if you create these transactions, and you can create these transactions by using other DAX queries or by using SQL queries, this depends on what you want to do, you will obtain this scenario. You will obtain one period that is everything until the end of January, and then everything from the 1st of February to the end of February, and so on. And our technique that we have seen before will just work. The problem, however, I mean, can we apply this technique to the model that I've shown you before? Unfortunately, no, because we have an issue that we cannot solve easily in Power Pivot, but we can solve in Tabular, which is the following. The transaction that I create at the beginning of February requires not only the quantity, but also the value. And the value has to be the final value at the end of January. Unfortunately, I cannot create a calculated column that generates the calculation month by month. The calculated column is evaluated all at once. What we have to do is this. We summed the value, the purchase value of all the transaction of purchases in the period. We do the sum of quantity, and this is what we did. And we obtain the price. Value divided by quantity is the price. This is the quantity of all the purchases. We are considering all the purchases in that period. Now, at this point, we can write this price here, and this price multiplied by the initial quantity is the initial value of the period. The problem is that I don't have a technique today to say to DAX, I want to create this calculation in a calculated column, because you should depend on other rows that you evaluated before. Unfortunately, DAX does not have recursion. And not having recursion, this calculation is impossible in a single statement or in a calculated column. So this is the problem that we cannot solve unless you do by hand this problem, dividing the periods in different tables or in different worksheets, or it's a manual process. What you can do in Tabular, and this is the part of the presentation that I will require 2 hours to show how we solved this in Tabular, creating partitions. We fundamentally used partitions in Tabular to split the calculation in different steps. And instead of using calculated columns, we used the partitions, applying the calculated columns as part of the query that feeds the new partition. And this is the idea. So in this way, we created this process in several steps. If you are interested, send me an email. I will provide you some example. So this is the final part. We should use, sorry, let me go back. Once we sum the value that has been obtained by the previous period plus the value of the following purchases, we apply this here, we obtain the price, and we repeat this process every time. So this is the recursion that I was mentioning. Let me check. Okay, so I think we have, okay. In this case, what we obtained here in this example is the part of the calculation that allows us to evaluate the value of each product in each period, which is this price. So this is the result of a DAX query that can do this evaluation. And in certain conditions, this could be enough. This is what we can obtain in DAX. Now, why you should use this? Fundamentally because if you need to apply the calculation to all the transactions, DAX is much faster than other techniques that I used to solve the same problem in the past. If you try to do this in SQL, you will end up creating a lot of temporary tables, and you will see that DAX is much faster. This works very well if your period is 1 year. Because if your period is 1 year, this is perfect, because you do a single operation and it works. If your period has to be restricted to less than 1 year, this could be more difficult unless you use tabular and partitions. So we have seen that we can have different calculations for the quantity on hand, a dynamic one and a static one. The static one is based on snapshots. You have to evaluate the volume of data that you have to make a choice between the 2 options. And the dynamic calculation of the inventory valuation could be very, very useful for simulations. I have worked with companies that had to do this simulation to evaluate what was the best way to estimate the inventory valuation for fiscal reasons, because they can choose different techniques and they can optimize the payment of the taxes based on this, because fundamentally they can avoid anticipating too much taxes in this way, especially for those businesses where the price of the raw material changes over time. I had one company that, because they were trading steel, if they evaluated the steel with one technique or another, they could have been in the position of anticipating a lot of money 1 year, and the following year the price decreased, and so they could have gone in a credit for the taxes, but the point is that they would have paid for money that they didn't earn. So optimized inventory valuation with this technique was very useful because they were able to simulate different techniques and looking at the best result that they could obtain. You can see a few information about, a few links about articles that talk about this problem. And of course, if you have any question, yes? I tried to repeat the, let me just check. As I said, the session will be much longer, but if you look at this, the idea of the partitions, if you have the raw data doesn't change. What you can do, you can create one partition only for the transactions that close and reopen the inventory. So you create one partition per month, for example, but each month has only the end value, the quantity to close the stock and the quantity to open the stock in the following day. But this partition can evaluate also the value, not just the quantity, also the value, right? And just to give you an idea, this is a real scenario where we have the partition that has all the transactions for 1 year, and then we have one partition per month that contains just the out of stock and open. In reality, you have to evaluate the volume of data, because every time you do the end period and open period, you're writing one row for every product in 2 rows. So if you have millions of products, as you see, it is expensive, because even if you have only 300,000 rows in this particular case, because they have many items, they have 50,000 items on stock, and so 100,000 rows every month. So you have to. The query that we have here, I don't know if we have an example, not here. The query that we write here is something like, no, we don't have this here. Fundamentally, the idea in reality is relatively simple. For every month, what I wrote in the calculated column will be in a column of the query. So when I write the partition, I write a transaction that also has the value. And the value has been evaluated with the same calculation that you have seen before. That's the idea. I don't know if I answered the question, but... Okay. Other questions? Okay. Thank you very much. If you have other questions, you can... Anyway.